the end of the presentation and the Q&A session. Thank you again to all the speakers. I hope you stuck around. So I'm going to be coming back to you in a couple of minutes and inviting all the speakers to join the panel session, where we'll be discussing some of the key takeaways from the breakout rooms. Before I do that, I'm just going to share the results from poll 3. Hopefully you can see those now. And excuse me. So it's interesting. Yeah, we've asked the same question in slightly different variants. First of all, we asked about the road system, then we asked about the vehicle system, and then we asked about the road and vehicle system of systems. And we've had different areas of emphasis in each of those sets of answers. And what I think is quite interesting here is that, unlike the others, standards has come out clearly on top when we think about the system as systems. So I'd like to come back to our first speaker from this session, Pete James. If you're still there, Pete, unmute. And what do you think about that finding? Okay, seems like Pete's not available right this second. So I can see Matthew's still there. So we'll come to you on Matthew. What do you think about that finding on standards?
Well, I would describe myself as a fan of standards. Is going over the top, but I think it's vitally important. The challenge with standards is how far do you go to create something that everyone can innovate from. If you go too far and establish too rigorous standards, then it makes it more difficult to actually go beyond the standards. So I think the issue is there's a lot of work required in standards to take it forward, rather than we need a huge number of more standards. There will be needs for more standards, but we need to work as an industry to reach a balance point that is useful for giving confidence to everybody to move forward from an agreed foundation.
Thank you. Yeah, so I'll come to Alex Mouzakaitis again now from JLR. What do you think about those poll results? Did they surprise you? Did they tell you anything?
No, I think you're absolutely right. You did ask 3 questions. What does it mean to the transport? What does it mean to the vehicle development? What does it mean to the combined? Personally, I'm not surprised. I think if I remember well, the vehicle, it was something split hairs between skills, industry. I think industry collaboration came first, and then I think it was right people, right skills. I think when you look in the vehicle and the link to the infrastructure, I think the anxiety of safety always brings back to the standards being the first line of defense. So I think naturally people will converge into the standards. But I think I thought one of the speakers earlier on, when he commented on the polls, it made a really valid point. You can write standards, but it's what work have you done in advance? And I think it was a hint there on government funding to ensure that the standard is written in a way that adds value and also leaves room for innovation. So, but I'm not surprised looking the answers. That's the short response.
Thank you, Alex. And Pete James, are you able to join us again now? We didn't hear from you before. I can see you're on mute, so if you'd like to unmute and give us your comments. No, doesn't seem like Pete's available. So on that point, we're going to go straight into the panel session. So if the speakers could share their video if they're comfortable to do so that I know who's here from the speaker panel. So we've got Matthew Clark, we've got Alex Mouzakaitis, we've got Andy Fisher, we've got Ian Cunningham and Neil Sinclair. Welcome back, all of you. Thank you very much for your contributions earlier, and thank you for joining us for the panel. So we held 2 breakout sessions earlier on today. The first of those where we discussed orange plate detection for hazardous loads entering tunnels, and we had a number of rooms discussing that. Each of them have come back with their key findings, and there's a bit of similarity there and a bit of commonality. We've got 25 minutes. We've got so we've got about 12 minutes for each room. So the first room, where we were talking about orange plate detection for tunnels, we found a couple of key takeaways. One of those is that we're going to need two-way communications in addition to the orange plate. So Matthew, I know you were involved in the Dartford tunnel crossing, so let's kick off with you. What do you think about that? Everybody instead of being told to put an orange plate on, they have to have two-way comms to their vehicle.
I think, yeah, I can see how there might be some functions that would be useful for that. But when we were talking about it in our group, the established kind of hierarchy of interventions is to educate, inform, engineer, and enforce in that order. So you're starting off, you really hope that by educating and informing people that's all you need. It's perhaps a slightly naive view, but that requires a kind of one-way exchange of information. But that is to the road users, and that might not be during the journey. That might be in advance of their journey. But you can see how useful it would be to actually enforce the fixed signing at the side of the road with, more urgent messages as they approach a sensitive location that is relative to their journey. So I can see how that two-way communication would take place. My vehicle, communicating from the vehicle, I am a vehicle that is of interest to this location, and communications back, well, you need to do something about that. So you can see how that two-way communication would be useful.
Okay, thank you. So let's go to Neil Sinclair for an automotive perspective on that. I know you've worked at an automotive OEM. How would you feel about that?
Well, just to the question that you've posed, actually, as a systems engineer first, I don't think the problem statement is clearly articulated, because the statement is more solution orientated than it is actually problem statement, if that makes any sense. And we could have ruled out a number of solutions for this just by how this has been sort of documented from my perspective. So I think systems engineering, one of the things I think is about, whether the solution that's there actually is correct for the stakeholders. So at the moment, I don't really understand the stakeholders that this should address. So one of the things systems engineering would do is we clearly identify all the stakeholders here, because we've got the one of the solutions could be that the hazardous material is registered by whoever the truck firm is, and all you have to then do is make sure you can use the onboard tracking system on the truck to identify when a particular truck might go through a tunnel or this hazardous area, because I think really it's hazardous areas we're talking about, isn't it? Mm-hmm. And then either warns the driver or prevents or stops the truck, or if it's an autonomous truck, parks it somewhere in some form of lay-by. So it just when we were talking about this, it felt like we needed to go back to the problem statement and identify all the stakeholders, really, if you know what I mean. So not answering the question clearly there, but more, I don't know, the people that were in the room, it was more, we wanted to go back to the problem statement and the stakeholders that were driving that, really.
Thank you. Okay, then that's a really important message for anybody who's new to systems engineering, I think. So another room, one of their key takeaways was this relates to stakeholders. Responsibility and ownership for leadership to resolve the issue is one of the key challenges. So in this case, we might assume that it's likely to be the highway body that's responsible, but the solutions must be collaborative. So that was one of the key takeaways. So I'll come to Andy Fisher, who is responsible for innovation on national highways. So nobody better to advise us on how we resolve this responsibility for ownership and leadership.
Thanks, Stephen. Yeah, it's a good question. Actually, I was in the same group as Matthew, and we kind of agreed to wait until the Lower Thames crossing opened and send trucks that way, because we don't quite understand the scale of the problem at Dartford. Much in Neil's thought process, we don't how often are errors and of driver errors occurring that we have to find this alternative solution. Should it come from us? No. Well, it is our road, is our responsibility to manage them. It's under our license, as prescribed from the Department of Transport. So it is up to us to lead and find solutions to problems. It's going to be entirely collaborative. I kind of think, well, in terms of this sort of level of communication between the vehicle or the driver and ourselves, who's going to be responsible for ensuring whatever is kitted out appropriately? Because obviously, once you product developers of all sorts, I suppose we're coming back to the standards. There's going to be a lot of different products on the market to be able to say this, that, and the other, and we've got to make sure we're all doing things correctly, or else it's just going to fail. You don't innovate for the sake of innovating.
That's a good point, and it comes back to the hierarchy, I think, that Matthew mentioned. So coming over to Alex Mouzakitis from JLR, what do you think from an OEM's perspective? Yeah, how would you get involved and collaborate with the Highways Agency to solve this kind of problem? Bearing in mind, it doesn't have to be a truck that is carrying a hazardous load. It could be any type of vehicle.
Yeah, it's a good question, and I think the previous presenters did cover really well. I think Ian said you're looking and for any form of collaboration, I think it's really important to crystallize what is the problem. Yeah, and before any solution is proposed, what's the problem, and what does it mean to each of the partner? What does it mean to the infrastructure? What does it mean to the OEM? But actually, what does it mean to the end user? And very often, that it is what really matters. Of course, Jaguar Land Rover has collaborated on a number of initiatives. I think it was mentioned earlier on Autodrive. Actually, I was co-lead of the Autodrive project. It was my 5th or 6th one of government-funded projects at large scale. So yeah, I think it's got to be a consortium that it's got the right expertise. The right vision and mission has to be set to achieve tangible results. There have been examples in the past of which, and they are well documented in the industry, of which many collaborative projects have resulted in very little benefit. They always result in some benefit, but I think that has to be understood. Who are the key stakeholders? What it is to be achieved, and the vision and the mission, what to achieve and by when. And I think that is a key ingredient for any form of collaboration to have any legs.
Thank you very much. So one of the other rooms observed that orange plates is something in the UK only, but how's this going to work across borders, considering future technology, global transport? Even if we find a solution for the UK, cars and trucks are sold around the world. So Ian Cunningham, you work for a supplier to the global automotive industry. You might end up developing the type of electronics that delivered a future solution for this.
Well, probably more the software, but yes, yeah. So I guess the key is the basic capability, and I think that's probably, to go back to the point about the standardization. The standardization shouldn't try to define everything. It should try to define a minimum set and obviously then that allows the innovation to be there, which is obviously going to be important, because as needs evolve, like, oh, we need to accommodate foreign vehicles or other transport networks, so multimodal transport maybe needs to be, it's not just about road, maybe we have rail freight going through sensitive areas, maybe that needs to be accommodated. It's a bigger problem, which maybe also comes back to Neil's point about what actually is the problem that we're trying to solve. Are we trying to protect sensitive areas, and if so, is just thinking about roads actually the answer? Are we being unduly restrictive?
Thank you. I'm going to go over to Neil Sinclair, who would like to interject, I think.
Yeah, I mean, there's a lot of different bodies here, but there's if you like, there's already a model in the aviation industry. So we have EASA, we have the CAA. These are governmental institutions that apply and work with OEMs to make sure that aeroplanes can fly in air lanes, that airport infrastructure has the right kind of infrastructure to accept aircraft, and that things fly at the right with the right safety margins and all of that kind of stuff. And it feels to me like that's what's missing here. That's what's missing in the automotive industry, is some form of equivalent that then coordinates the manufacturers, the standards, the people putting the infrastructure kind of thing as well, you know, because we've got people like NATS and other people. That's really what's required. And for a long time, the automotive industry was a highly unregulated arena. Yeah. And it feels to me like governments need to, or some governments need to put something like that in place to then coordinate and give industry and standards bodies and other people a framework to work within and get agreement. Because otherwise, it's like herding cats. And the only real way of herding cats is to get some very nice food somewhere and try and get them to follow it, but it doesn't always work. So it feels to me like we need that EASA or the CAA or whoever it is that is governing this. And so there's a local national CAA or automotive CA, whatever we're going to call them. And then there's a more larger body like the European body, and then an international one. And it feels that's what we need, because, you know, even the cybersecurity, ISO 26262, there's contradictions in these different standards. They don't fit together. And part of the reason for that is there's no higher coordination there that's helping that. So there you go, that's my rant.
I'm just hearing a bit of background noise. Could I ask all the delegates to mute if you're not involved in the panel? Thank you. So yeah, just a very quick one from you, Matthew. I can see you got your hand up. Then we'll move on to the other scenario.
Yes, just to correct the emphasis in just a previous point, that this is orange plates are just a UK thing. They're not. I don't know exactly what the extent of their deployment is, but I know that all of the numbering systems that you find on HazChem vehicles are United Nations registered numbers. So it is an international agreement. I believe that certainly the orange plates are certainly European, but I don't know the extent of how they're used.
Thank you. Yeah, so some really good insights there. Definitely a focus on stakeholders and identifying the problem is really important. So we considered a second scenario, which was around the GLOSA system, so green light advisory. So this is when cars or other vehicles are approaching the traffic lights. They get information presented to the driver through a device in the car that tells them in the vehicle that tells them when to slow down, when to speed up, if they're going to make the light. We had some very interesting observations from several of the rooms. So one of the first questions there, which echoes back to what we talked about, was that the scenario presented did not consider all the stakeholders, and so there's concerns over how other road users, cyclists and pedestrians are represented. So yeah, maybe I'll come back to you again straight away there, Matthew, to kick off again. So you know, how do we consider all the stakeholders? It's not just people who are in a vehicle with a dashboard.
Yes, that's very true, and it's not a straightforward question. August last year, the Department of Transport issued guidelines for cycling infrastructure, which actually puts much. If local authorities want funding from the Department of Transport, it basically says you've got to do it differently. And it's actually saying you've got to put cyclists and pedestrians as a higher priority than vehicle traffic. So there's a real challenge, but I think the biggest challenge in actually deploying that is changing the mindset of the highway designers, who really are not used to thinking in that way. They design for vehicles, and for and actually accommodating things other than vehicles is not in their mindset. I think there's a real challenge there.
Okay, and Andy Fisher, designing for non-motorized vehicles is not part of the mindset. What do you have to say about that?
Hard to argue. quite frankly, yeah, Glacier is my least favorite of the CITS services, because traffic signals are not prevalent on our network, and in its usage on our network. I'm not entirely convinced there's a positive argument for the investment as such, but I can see it potentially having more benefits in an urban environment. But then, like you said, that you can't, if you're on a bike and a bicycle, you can't have access to a device that's going to inform you when the traffic lights are going to change, except the traditional red, amber, green, which is there in front of you. I think whilst we're looking at different types of services for when we connected services, it's at its core will be providing information where there currently isn't any. Gloster is very much supplementary, and it's about being slowing down slowing down your speed to make sure that you're going to get a green light without stopping, etc. And so it has benefits potentially for air quality and stuff. Whereas if you're on a bike, I think that's you're already winning in that regard. So yeah, I guess there's no one size fits all in this, and if there is a way of providing infrastructure for not NMUs to be able to be part of it, then great. But I think we've got to recognise that the whole fleet, from vehicle to whatever type of vehicle to whatever type of road user, is completely different, and they all consume information completely differently. And yeah, there is no one size fits all model. So, but that shouldn't discourage us from not doing anything.
Thank you. So another room was concerned about security and the potential for these type of systems to be spoofed, and that could happen both on the highways end. We could an attack could take place on the traffic lights, telling people that they were green or red when they weren't, or it could affect the in-vehicle system with similar results. So we've got risks of national level gridlocks and all sorts of things if people were sufficiently coordinated. So that's a difficult enough problem to deal with if you're just responsible for the car or just responsible for the lights. But with nobody taking overall responsibility for the combined system, perhaps that's even more difficult. What's that like from an OEM's perspective, Alex Mouzoukitis?
Yeah, that's a good one. It is a really good one, because the primary area here to address is clearly safety. Yeah. Yes, you could save fuel, you could save CO2, but you wouldn't do any of these things in the expense of safety. So safety is really important, and I wouldn't be the one to do the FMEA for such a system. However, what I do see that a potential deployment to production could occur is where there is a highly controlled area, a designated area. So I could see a designated area of which you get the advantages of more advanced V2X. You get the advantages of perhaps having zero emission vehicles driving in. Maybe it could be EV only area. It could be a city. So for designated areas, I think you could perhaps design such a system in a way that is designed against the right software integrity levels. And I don't think it's one of the rooms that I was, and I apologize, I couldn't participate a lot. But very quickly, I think the room came into, oh, this is one of the solutions. And my view is, it's not just the vehicle and the traffic light. It's a vehicle in the infrastructure, because you still need to know the road traffic. You need to have your e-horizon data. They've got to be robust. But I think for a highly controlled and designated area can be designed, but it would be a lot of work to make it safe.
Okay, thank you. Yeah, so that's another interesting aspect. Not only have we got to understand the stakeholders, but we've got to understand the scope of the problem and the scope of the solution, the space that we're trying to address. Thank you. So another room was interested in the risk of a gamification problem. Actually, a couple of rooms had that point. So, if we're giving drivers this additional information, what are we doing in our systems engineering to consider human behavior? Are people going to try and speed up to beat the traffic light just because they know it's about to change, for example? Neil Sinclair, what do OEMs do from that perspective, thinking about human behavior?
Well, for gamification, I think is an interesting one. I'm not sure OEMs have really thought about that yet. And it depends on where technology goes, doesn't it? Because in the future, if we are in certain black spots, cars might only be able to be operated in an autonomous mode. And if that's the case, then you couldn't gamify that kind of thing. Yeah. But I don't think that's something that is being considered as far as I'm aware. And to be honest with you, gamification, if you really get down to it, being able to have a really big engine in a fast car, cars are gamified already, because people do it for the thrill. And you see the boy racers driving around, or even older people in faster cars might drive not how they should do. So I don't think you can remove that per se. But you might not give that information to the driver, so you can't gamify it. But then if you were in a fully autonomous mode, then that information the system could use, and the driver wouldn't obviously intervene to be able to gamify it. Yeah,
I'll come to Ian Cunningham. From a software supplier's perspective, this human-machine interface, what are we doing to secure that as it gets more and more complex? What are we doing to ensure that people follow the instructions rather than misinterpreting them?
Yeah, well, I was going to say it's probably more misuse. So kind of picking up from what Neil was saying, you may have someone who's in an autonomous car whose car is going to perfectly obey the instructions from the system. You may have somebody behind them who's realized that if their passenger has their smartphone app on for picking up the signals, they can work out that the car in front of them is going to slow down and try to overtake them and beat them to the lights. And that kind of unintended abuse of the system or use of the system is a real challenge that needs to be addressed somehow. So within the system design, I'm not sure how you would address that in the design, that kind of deliberate misuse of the system. That's a really interesting question, those kind of misuse scenarios.
It's certainly a conversation I've had very often in industry as a consultant. A lot of people think of lots of clever things that technology can do, but they don't spend nearly enough time thinking about the clever things that technology shouldn't do, or how it could be abused. And I think there's a lesson for systems engineering in general there in this space. Alex said, safety's always got to come first, and you've got to think about how, as we involve the human in new and different ways, how are we going to keep everything safe as we become more innovative? So we're nearly out of time.
Can I just add one point? There's one thing we haven't discussed today, because there's been lots of discussion on technology, But black swan events, things that are low probability, high impact, such as COVID, can happen. So, for instance, we need to start thinking about things like coronal mass ejection from the sun, which knocks out road infrastructure or some of it. And these are the kinds of things, I think, those negative scenarios that maybe systems engineering could help with as well. But everyone's assuming that the electronics are going to work all the time.
Yeah. Assumptions are dangerous is one of my mantras in engineering. So, so that was a quick final word from Neil there. I'll come to the other speakers. Just a literally 20-second wrap up. So, Andy Fisher, 20 seconds, final thoughts for the day.
I never thought I was involved in system engineering. It's abundantly clear that I need to start reading up on it.
Okay.
It's been incredibly fascinating. Yeah, no, thank you very much.
Well, and thank you for taking part. And there's an important message there. You know, even if you don't think you're a systems engineer, if you are working in this space, then maybe that's something you need to think about being. Matthew Clark, final word from you.
Yeah, I've been trying to introduce gently systems engineering into all the work that I've done over the last 20 years, probably, with some success and some failures, because systems engineering is not really part of the culture of the highways industry, and I think that has to change. I think we need to be much more collaborative with our colleagues in the automotive side. And this is a very good opportunity to start doing that. Yeah, I think that echoes Neil Sinclair's point. You know, we've got to think about people, you know, the stakeholders around this. Thank you. Yeah. Final thought from you, Alex Mizikaitis.
Thank you, Steve. I think for me, it's if we can embed more of engineering curiosity within the systems engineering, it would be the benefit of all. I think we've got to be brave and recognize where systems engineering has worked, where it hasn't worked, and like every other methodology, process, whatever that framework, it will evolve, it will continue to evolve, and we've got to make it in a way that our engineers collectively, regardless of what's the industry, they deliver value on every single engineering artifact that they create. So I think putting engineering curiosity and technical curiosity at the heart of the engineering, certainly I believe is the right thing to do.